Okay, interference. So when two waves move in opposite directions and they meet, you might think, kind of like this situation, right? You might think that they could bounce off of each other, right? But that's not what happens. They pass right through each other. But when they do, something called superposition happens. They superimpose on top of each other, or we say that they interfere with each other. So what this is doing is it's creating a temporary wave that is the sum of the two waves that were coming. So you can kind of see that happening here, right? You've got this wave pulse going this way, this one going this way. When they hit, they superimpose. They constructively interfere with each other. Constructively interfere. That's what it says up here. So constructive interference. And they build. So the new wave that is temporarily made is twice the amplitude. It's going to be this amplitude plus this amplitude for this one, right? And then what happens is it's not that they bounced off each other. This wave pulse is now over here. It traveled right through it. Destructive interference is when you've got them coming out of phase. So phase, just to go back a minute, these were in phase because they were both on top. So we'd say that in phase with each other. These ones are out of phase. So when they come, they're going to come, and then right when they hit, you can see nothing's here. That's because they destructively interfere with each other. So if I took this amplitude and added it or subtracted this amplitude, I'd have nothing left. So they destructively interfere and they're gone for a second. And then they continue on carrying. So this wave pulse is now over here. This one is now over here. So this idea is something called the principle of superposition. And again, click on these video links to see some examples of this as well. I don't have a simulator that shows this one. Okay, so in kind of summary, we've talked about stuff in one dimension, right? But if you want to talk about waves in two dimensions, so we're kind of talking about like sound waves at this point, you can kind of see it would look something like this too, right? Where the dark lines would be the troughs and the bright lines would be the crests of our wave. So you could talk about this as being in two dimensions, but more accurately, sound would be a wave in three dimensions, and that can happen as well, right? So just if you were coming out of the computer screen, it would look like that. If you were talking about constructive and destructive interference, we're going to talk a lot about this in Physics 30, but you'd be able to see that these two, where they meet over here, you can kind of see it's like a checkered pattern now. Spots where it's dark coming across here is going to be where it is destructively interfering, where they're canceling with each other. Spots where they're bright are going to be where they're constructively interfering with each other. So this happens in real life in two dimensions as well. Okay, so I want you guys to go ahead now, and we're going to play with slinkies or those snakies. This is really all you need, just a long coil spring. And I want to make sure, though, that before you guys do, if there's somebody else with another one doing it too, don't let them touch. They're going to tangle, and you're gonna wreck them. They are quite easy to break or quite easy to stretch. Don't be ridiculous and like get like too aggressive with them. You will stretch them and wreck them, right? So just don't be too crazy like that. The other thing is if you tangle them, they are a pain in the butt to get untangled, and you were responsible for doing that, and you've probably stretched it too if you tangled it. So try your don't do it. Just really be kind with them. So I'd like you to get a partner. You're going to be doing this type of thing with another student or a teacher or anybody around you. Really, they'd probably like to play with a slinky too, even if they're not in the class. And it's going to be back and forth on the floor. Don't like lift it up in the air, but just back and forth. You can make transverse waves that way. You can make longitudinal waves that way. So once you've kind of pretty much gone through these and played with it a bit, look closely at the questions in the observations and analysis section. Conduct experiments to answer each question. So that would be this part. So you're going to answer these questions with that. So go through and yeah, just answer those questions. That's pretty much it. I shouldn't say that's pretty much it. Then you're going to do the handed assignment. So go ahead and do your handed assignment. You can see that it's going to be a lot of theory stuff. There's actually not that much to do with math in this one. So go back through the notes. Make sure you have a good grasp on this stuff. Okay, so that's it for that one. Have fun, and I'll talk to you guys in the next lesson.